Good afternoon, my students. Today the topic of our lesson, derivative. Increment of an argument, delta x is x minus x0. Increment of function, y is of function, delta y is f of x minus f of x0. Definition of derivative of function y of x at point x0. Y derivative is a limit increment of function over increment of argument as in delta x tends to 0. Derivative of function at points x0 is the limit f x0 plus increment x minus f x0 over increment of x tends to 0. If this limit exists, then a function is a differentiable function at the point x0. X prime, x second prime or double prime, triple prime, a first prime, a second prime, a second prime cube, a second prime sub c, a second prime. The first derivative of z with respect to x. The second derivative of y with respect to x. The nth derivative of y with respect to x. Y is a function of x. Y equals f of x. Geometric interpretation of the derivative. Consider the function y f of x and where alpha, slope, angle of the second, AB. A derivative of function at the point is a slope of a tangent of this function's graph at this point. Tangent equation y is fx0 plus f derivative of x0 times x minus x0. With properties of derivatives and differentiable. Properties of derivatives and if u of x constant, then u derivative is 0. If u be differentiable functions at the point x0, then satisfy condition. Derivative of composite function differentiate the outside function f and evaluate it in the inside functions g. Derivatives of elementary function and seem stationary points. Definition: stationary point. Stationary point of function f is the point c of c, where c is in the domain of function such that f derivative of c is 0. For y is of function dy over dx is 0. Stationary point. Note that a stationary point is a coordinate pair x, y, and all stationary points are critical points. Find the stationary point of the function. For x cubed, minus 3x squared plus 9. So we must differentiate it and find values of x for which f derivative of x is 0, f derivative of x is 12 x squared minus 6x. 6x is 0, x is 0, or x is 1 over 2. X is 0, so f of x is 9, and x is 2 over 1, 2. Function is 35 over 4. The stationary points 0, 9, and 1 over 2, 35 over 4. If derivative of function greater than 0 for all x within an interval, then the function is increasing for the interval. Increasing function. Look at the picture 1, 2, 4, increasing function. If f derivative of x less than 0 for all x with an interval, then the function is decreasing for the interval. Consider the maximum stationary point. To the left of the maximum stationary point, the function is increasing, and to the right, the function is decreasing. Therefore, by the definition of increasing and decreasing function, the derivative has changed sign from positive to negative. Consider a minimum stationary point. To the left of the minimum stationary point, the function is decreasing, and to the right, the function is increasing. Therefore, by the definition of an increasing and decreasing function, to the derivative has changed sign from negative to positive. First derivative test. This process is known as the first derivative test. If the sign of prime of x change from positive to negative at the side of the stationary point, then it is the maximum form. If the sign of prime change from negative to positive at the side of the stationary point, then it is the minimum point. For example, find the stationary point y is 2x cubed minus 6x plus 2 and determine their nature using the first derivative test. Solution. Differentiate it and find values of x for which y derivative is 0, and then evaluate y derivative at the side of the stationary point to determine the nature. For example, 6y is 2x cubed minus 6x plus 2, y derivative is 6x cubed x squared minus 6. X is plus minus 1, x is 1, y is minus 2. X is minus 1, y is 6. We must now determine the nature of the stationary point using the first derivative test. At the side of x minus 1, y derivative change from positive to negative, hence minus 1, 2 is the maximum point. 1 and 6 is minimum point. first derivative test. We have considered the first derivative test when the gradient changed from positive to negative or from negative to positive. It is possible that the gradient does not change on either side of stationary point. To answer this, we will consider y is x cubed.